So as you can see, I got it going. I got 3 tracks going anyway. So I'll show you how we got there basically, because there were some things we have to deal with. Okay, so we'll show you that in a second. Greetings, folks. This is Scott with the Game Audio Institute, and we are back within our realm of Constellation and doing stuff inside Unreal and blueprints. So where we last left off in our grand journey of all of those things was we had 3 lanes going on our thing, and we'll get more of that stuff going, and I'll show you kind of what I was doing there, but I also do want to show you some cool stuff about what's you basically sending messages between blueprints, which is a thing you have to do, and sometimes it's not very obvious. In fact, there's very little documentation about how to do this oftentimes. And this is basically using a combination of event dispatchers and custom events, essentially. Okay, so we'll show you how that happened too, because that took quite a long time to figure out, and there's still some more stuff to figure out because it's Unreal, and yeah, it likes to do things its own way. Anyway, so that's basically it. I'll go into the Unreal stuff, and we'll show you what the heck was happening and where we're doing things. So probably the biggest thing to talk about with regards to all of the changes that I've been working on is, and it's actually part of the reason why I ended up having to, what happened was I was getting a situation in which when I got 3 layers going, it was in fact stopping after a while. So like basically we get about 4 or 5 repeats in, and then basically 2 out of those 3 layers would just stop moving. And then the third one would keep on going. Okay, so if we can recall what we've been doing up till this time, we have our playhead here. And what happened in our what we're missing now, is, as you can see, is this big huge gap over here. Is we no longer have any of those quartz metronome things happening there. So they were happening per line or per row, because this is basically per playhead, and basically there's going to be 16 playheads, right? So technically we were creating ourselves these individual metronomes that all had the same name. So they were tripping over themselves, and the fact that they could even manage it for like a little bit is pretty amazing. But basically what happens is that 2 of them basically get thrown in the garbage, and then one of them keeps on going essentially after a while. So this is, a problem that I ran into. And so what I realized I had to do was that I had to basically take all of that stuff about that quartz metronome and things like that and put that in the layer blueprint, the trigger layer blueprint, which is exactly what I did. So all of that quartz metronome stuff has now been placed into the layer blueprint, which is what it should be anyway, because that's really what's going on. In fact, honestly, it probably could just use only one single metronome for the entire thing, with everybody else just sort of interpreting things from that point. But I do like the fact that you can have quantized outputs. So that might be a thing of like maybe having more than one, but starting them all at the same time and stopping them all at the same time, potentially. At least for now. Who knows? Maybe that'll be a thing that I can do later on that might be cool and interesting. Start and stop at different times, possibly. Anyway, so the deal is that I ended up doing, so this was all the stuff that I had. So then I'm faced with this idea, well, okay, I need to get information from this event graph, this trigger layer, right, to the playhead blueprint, basically, okay? And so that creates a whole nother situation. Now, before we get too heavily into that, I do want to sort of talk about a couple of cool things that I did with the playhead. So what I wanted to do was make sure that when I had playheads, that they would automatically sort of like put themselves at the right vertical position. Vertical, by the way, in Unreal is Z, right? So Z position, basically. So the idea is that they'd all be, spaced up a certain amount. And remember, previous videos we talked about that I had what I wanted to do was make sure that I kept the spacing. The spacing, remember, is going to be a variable that will happen all the way through the game. So the spacing between each of those little cells is going to be variable at any time. You can basically make the constellation bigger or smaller. So that means you're going to be changing the spacing between each of those objects essentially. So that's a thing that I'm definitely working on and trying to deal with. So what happens now is I am going to what I wanted to do was figure out how to basically calculate a position. And so it was pretty easy actually. A couple of little back and forths, but basically I did manage to do this pretty well. So let me show you how that worked. And we had to do it a couple of different ways. So first of all, we have the good old event begin play. That's extremely necessary. We have to have that. Let me just get around here, go back here. Okay, so the deal is we had to have the event begin play right over here. So that's going to start the thing. We're going to go to the sequence because I wanted to do more than one thing when I first start the game, basically. So here we go. The event begin play. So the first thing that we're going to do is we're going to grab a lot of information about where things are at, and we want to then change the variable of the z, the height, basically, based on certain kinds of things. So essentially, here's the deal. I've just got the origin position, y, x, y, and z for basically, my object, right? And then in this case, I basically am taking the origin of the object, the playhead itself, and then I have the spacing variable, which can be set and is basically global but also changeable. And then you have this height multiplier. Now, the height multiplier, on the other hand, is a very specific thing, and so I wanted it to be instance editable, right? So I wanted it to be able to be different per playhead. Okay, that's the important thing. So because of wanting it to be different per playhead, now I can create a variable that'll be different for each playhead object. It'll be sitting there in the details or the whatever they call it, properties. I guess it is details for that object once I select that object, in the outliner, right? Okay. So then what happens is I take that, I multiply that information by the spacing to get the total amount. Now, what I know is the spacing right now is about 200 units, right? So the idea is that it's 200 units, and therefore I'm multiplying that 200 units by the height multiplier, and then the output is going to here. And then what I'm doing is I'm adding that variable to the z position and sending all of that information to this copy of the set actor location. And the reason why is just I just want to make sure that it positions itself correctly, pretty much just like at the very beginning of the scene, right, or the level or whatever. That's the idea. And then in addition to that, you can see I'm splitting off that pin. I'm also sending it to the new location Z, because what this does is this keeps it going basically in that line, in that vertical height of whatever it is for that particular playhead, and then it'll basically go there. So that's all happening there. I managed to basically reduce I did a bunch of stuff on the MetaSounds front. Wasn't really too much there that's going on. This is all the same as before. None of this has actually changed. But I did want to make sure that the playhead was automatically going to set its own vertical location automatically based on the height that it got from before. Okay, so we've got that going on. Okay, that's dealt with basically at this point. Now, we've got ourselves a blueprint that we want to basically send a clock signal to another place, another blueprint, okay? And this is done using event dispatchers. Now, this is not exactly the event dispatchers. This is a quantization event that's automatically hooked up to the subscribe to quantization event. So the idea is you could have a bunch of different subscribe to quantization events. I could probably create custom events, maybe on each of the different things that would subscribe to the quantization event from there, potentially, I suppose. Anyway, but we'll deal with this. So what happens is that this creates the event, and then it's called get layer clock. And then get layer clock, this is kind of similar to stuff that has already been here, really. And we'll move this down. Okay, right there. Get layer clock is the custom layer event. Okay, so this is all still internal to this script and everything like that. And so what I really wanted to do, all I really need to do is I just get a tick. That's it. Just a tick at a particular, quantized amount. In this case, it's like an eighth note, but technically it's going to be like independent per layer, So right now we've just got one layer going on. So we just pick up a quantization and that'll be basically what will happen. But in the final version, it will definitely be changeable. You'll be able to change the level of quantization essentially. So basically now what happens is all I want to do is get the clock information to be sent to the other blueprint. Okay, and in order to do that, I need to basically use an event dispatcher. So over here, I create this event dispatcher called getClock, okay? And I tell it that it also needs to have a beat input. You can do that by clicking this plus sign and clicking new parameter, and you can add a parameter to, or any number of parameters. And this is going to be very useful, of course, because if you have games that have like lots of parameters that need to be given, like say the player location and their health value or something like that, then basically, you can basically transfer this information. You can basically transmit this information if you need to. In my case, I didn't really need to do this too much, and maybe this might have worked without even doing that, but I felt like I should try and do it anyway, just to get an idea of this. Again, I don't really need this beat value. All I need is literally a click or an event tick that's happening at a particular speed. That's all I need to do. So anyway, the most important thing to understand about this is that this is what's called an event dispatcher. An event dispatcher basically has two modes. It has two modes. The first mode is called calling, okay? Calling is done by the source, okay? Then you have binding, and binding is done to the target. That's the deal, okay? Now, there may be all kinds of other ways of doing event dispatchers that I don't know about. This is the one that I do know about. So the thing that's very important to understand is that the calling takes place on the sending object, but the binding takes place on the destination object, right? Or it could be taking place anywhere, even in the main script, if you really wanted it to do that and you just didn't want to have a bunch of, cables hooked up and stuff like that. You could do it on the same one. And in fact, actually, what we find out is we need to do that initially because there's some weird stuff that goes on. So let's go take a look over here. So what we've done is, all I've done is I've just taken the beat value, I put it into a set value. Again, this may not even be necessary, really. And I've called getClock. There's the beat. And then I have it print the string. And there's going to be a lot of printing strings I have to sort of turn off because it prints quite a lot at this point in time. Anyway, so the deal then is I've got that going on, okay? And then it calls getClock. Okay, so now what do I need to do? Okay, so on the destination object, here's what needs to happen. On the destination object, we're going to go back over to here. We need this bind event to getClock. Now, this is tricky because you can create a bind event here, but the thing is that the target here has to be hooked up to the original trigger layer calling blueprint. In other words, the source. And it cannot be created here or found or instantiated, as far as I know, here directly by itself. Like this is the thing that was really confusing me. So you only have to create this event dispatcher like once, but to create the bind event to the right to the getClock object, you can't do it. You can bind to the event to getClock, but then this target is going to be different. Notice how the target here says trigger layer blueprint object reference. Okay. If you create this bind event to getClock, it will have a reference of the Playhead BP blueprint, which is the wrong one. You don't want that one. So what happens then is you have to basically, this is the part that was weird for me, you have to create that event dispatcher, the bind dispatcher here, cut it out, or you could copy it, either one, and then paste it here in the destination, which is totally yeah, it's kind of not very intuitive in my opinion. But anyway, whatever. There's a lot of stuff about Unreal for me that's very unintuitive. Anyway, so the deal is that then you have bind event to get clock. Okay, so then this binds the event correctly because now it's pasted in the right location. When you pull out target, if you pull out this pin, then you can cast to this trigger layer blueprint, and that's what you want. And then you can create, in this case, I created a variable called layer actor, which is just an actor, which is basically just hooks up to the object and assigns it to the trigger layer blueprint object, and then it goes to there. Then once I got that, then I can drag off this pin here and I can create my own custom event. And this one's called get layer clock. And you see how the beat is not even being hooked up? I don't care. I don't care about the beat. It's all I care about is the execution pin, really, basically. So I got the execution pin hooked up. I hooked it to the print string to say print hello, but I don't even need to do that. Again, I could just go straight to this. And this is what does all the adding and the setting and the, all that sort of stuff that we had going on. So basically, that's how it works, essentially. So as a result of doing it this way, I end up with one clock for the entire layer that's driving all of those things. Now, what I can do, if I speed up our time, maybe, is I might be able to create more playheads and see what I can do in terms of maybe generating a whole bunch more stuff. But let's just see what we can do in the next video. But for this one, I will sign off, and I hope this helps you get your game audio on in Unreal and MetaSounds, potentially. See you later. Bye.